You know, for the longest time, the AI game has been all about one thing: size. Bigger models, more compute, more power. But what if we've been looking in the wrong place? What if the real secret to smarter AI isn't a bigger brain, but a better diet? Let's get into it.
And really, that's the big question we're tackling here. Just think about it for a second. The model's architecture, that's its brain. And the insane amount of data that learns from, that's its diet. We've been obsessed with building these massive brains, but some incredible new research suggests we've been totally overlooking the most important ingredient of all, the food.
All right, so here's our game plan. First, we're going to unpack AI's big secret sauce problem. Then, we'll introduce this idea of a racetrack for datasets and figure out the winning recipe. From there, we'll see how this gets us way better AI for way less effort. And finally, we'll zoom out and look at what this all means for the future.
Okay, so to really get why this new approach is such a game changer, you first have to understand this huge problem that's been holding AI research back. For a long time, we just haven't been able to make fair comparisons. It's been a total mess.
Here's the thing, and it's a huge problem, but it's also super simple. The big AI labs, the ones behind the models we all hear about, they don't publish their training data. They'll give you the finished model, sure, but they keep the recipe book locked away. And that creates this massive black box right at the heart of everything.
And this slide just lays it out perfectly. On the left, that's the world we've been living in. When one model outperforms another, we're left guessing. Was it the brain, the architecture, or was it the secret diet? Who knows? It makes real scientific progress almost impossible. But on the right, that's the goal. A standardized world where we can finally actually test what works and what doesn't.
And that brings us to the breakthrough. A huge group of researchers got together and built a solution. It's a new benchmark they call DataComp for language models, or DCLM for short.
Think of it like a Formula One racetrack, but for AI. For the very first time, everybody gets the exact same car, the same model, the same training rules, the same amount of time on the track. The only thing they can change is the fuel they put in the tank, which is their training data. Now at last we can have a fair race and see which data recipe is truly the fastest.
So, how does this whole racetrack actually work? Well, this diagram here shows the whole process. It's this really elegant four-step workflow that's designed to scientifically figure out how good a data set really is. Let's walk through it.
Okay, so first, step one, you pick a scale. It's like choosing your racing league, from go-karts to supercars. Then, step two, you build your data set, and you get to pick from this absolutely colossal pool of 240 trillion tokens of text from the web. It's just mind-boggling. Then, step three, you train a model, but everyone has to use the exact same training process, no cheating. And finally, step four, you evaluate that model on 53 different tests. Because everything else is locked down, the final score is a pure reflection of how good your data was. So they built this incredible new tool, and then they went to town with it. They ran over 400 experiments to finally figure out what makes a data set great. And what they found? Well, it's pretty fascinating.
The single biggest takeaway, the thing that stood out above everything else, was this. The key to a great data set wasn't some simple trick. The real secret sauce was using another AI to act as a filter.
So what the heck is model-based filtering? It's actually a beautifully simple idea. You take a smaller, super efficient AI and you basically turn it into a quality inspector. Its one and only job is to read through mountains of messy internet text and pick out the gourmet stuff, the really well-written, smart, coherent text. You then take only that good stuff and feed it to your big, powerful model.
But here's where it gets really wild. The researchers found that this little AI inspector was actually better at picking good data than human reviewers were. It's a totally counterintuitive result. And it kind of suggests that what an AI considers a 5-star meal might be a little different from what we humans think.
So armed with all these new insights, the researchers went ahead and created their own open-source dataset called DCLM-Baseline. And the results? They're nothing short of stunning.
Just look at that number, 6.6. A model trained on their carefully curated dataset got to the same performance level as the famous Llama 3 8B model while using 6.6 times less compute. That is a massive, massive leap in efficiency. It basically means you can get top-tier AI performance without needing a big tech budget, and that could completely change who gets to build these things.
All right, let's break down this table because the proof is right here. Look at that top row, the DCLM-Baseline model.
It scores a solid 64% on a really tough benchmark. Now look down at Llama 3. Yeah, it scores a little higher at 66%, but now look at the training compute. Llama 3 needed 15 trillion tokens of data. The DCLM model, only 2.6 trillion. It's crystal clear proof that data quality absolutely crushes data quantity.
So, let's zoom out. The huge takeaway here isn't just about one new fancy dataset. This research points to a fundamental shift in how we build AI. What this really does is it turns AI development from a kind of dark art into a real science. It gives us a ruler to measure data quality. That makes the whole process more accessible for everyone, not just folks with endless supercomputers. And of course, it's way more energy efficient, showing we can get so much more with so much less.
Now, to be fair, the authors are totally upfront about the limitations. This is just the beginning. Their dataset is mostly focused on English, and it's not yet a pro at specialized things like writing code or doing complex math. There's still a lot of work to be done on other languages, on safety, and on fairness.
But man, this really does feel like a new chapter for AI. It's a huge shift. It suggests that the next big breakthroughs might not come from the people building bigger models, but from the people who get really, really good at curating data. The secret recipe is finally open source, and the biggest question now is, what's everyone going to start cooking up?
This is for entertainment purposes only.